got another plug right here, bro.
Okay.
And then you got this.
Clear the memory.
Wouldn't that be cool if it had a little pop up? Like if it was an option, it would like pop up in the lower right corner.
Yeah.
You could just click on it.
It's not loading up on the TV. Not loading up on here anymore. So let's go.
Why don't you, oh, well, I reset it last night. By holding the on button, does that change anything? Yeah, I don't know. Neat. See, man, you got problem solving skill.
All right. I think we're good, fellas.
All right.
All right. I think we're good, fellas. All right. All right. I think we're good, fellas.
All right, man. So we just got up out of bed. Hold on a second. We're not doing it like that. All right, man. So we just got up out of bed. Hold on a second. We're not doing it like that.
That was like an echo echo.
Yeah, I wasn't gonna. Hey, I'd be like, "Hey, man. All right, everybody, shut up." Okay, so I decided to put all the little coils away. They're down there at the other end of the table. And I'll either use them or put them away. Right now I'm using this bad boy right here. It's a mini me Bedini. I was suggested to build the quote unquote Bedini coil this way with 7 strands of 28, a combination of 28 gauge and 26 gauge. This is what I came up with, so I call it the mini me Bedini.
Mini me Bedini. There's a
So
close up of the strands.
Yeah, there's a 128 gauge and 6 26 gauge strands. The way I have it hooked up is the 28 gauge is hooked up to a transistor. The number 1 26 gauge strand is hooked up to a different transistor. And 2, 3, and 4 are hooked up in series to the 3rd transistor. And 5 and 6 are hooked up in series to the 4th transistor. And there's 4 transistors here to run that coil. Then over there I have a 32 gauge coil, single file, just 1 strand, and It's got 22,000 turns in it. So I'm gonna turn the power on. Right now, currently all I have set up is a bridge. A bridge rectifier. Down there, the little square. So use a full bridge rectifier. And it's hooked up to the multimeter over there. Gotta reset it though,
Yeah.
turn it off. Alright, this is it running at 8.5 volts, 0.1 amps. It's below 100 amps, 100 milliamps, I mean. It's in between 0.5 and, or 0.05, I don't know. Below 100. And it's running really good at below 100 milliamps. Alright, so there's 10. 10, I'm gonna inch it up so that I don't shock anything into not working properly. Right now everything's working great. We're at in between 0.1 and 0.2 milliamps. No, between 200 and 100 milliamps. That's what I'm trying to say. 0.1 or 0.2 of an amp. Sorry, like I said, we just rolled out of bed and decided we're gonna do this because it works great. This works phenomenally well. What volts we got over there?
69.
Nice. You know that's already 7x. If we had 100 milliamps, or 100 amp, 100 milliamps. If we had 100 milliamps coming out of this big ass coil over here, we would be at 7x pretty much. But I guarantee we don't. I guarantee that that's only going to be at like right now, maybe 7 point, some really low, below 100 milliamps. So 0.01 or something.
If anybody has any questions about the setup, let us know.
That shaft is basically an iron shaft. It's steel with a more concentration, higher concentration of iron. It goes all the way down to the ground, and it's on a magnetic bearing. So how many watts is that, bro? 1?
That's 1 watt.
Well, that's all right.
Yeah, that's this over here.
1 watt. How many volts we got?
89.
That's awesome. That is freaking awesome, dude. And this is just, maybe it's just because we're actually doing everything right this time. I don't know. All right, 12-volt battery pack test. Testing. Let's recast it. Boom. 12.1 and 0.1. Still in between 0.1 and 0.2 amps. Oh, we got a tack. Get the test real quick.
Nice.
That's at 12 volts, 0.1 amps. We're gonna get it going up to about 16 before we can consider going higher. And then what do we want to hook up to the other end of the bridge rectifier? Oh, that's not right. 6, it went down some, like a lot. So right in between, I'd say 610, 615. And for the third test, oh yeah, it's going up pretty steadily, actually.
Yep.
And I love it how the amps are now down to.
Yeah, if you guys type out any questions, they'll pop up right here on our big screen.
All right, we're upping it now to 15. Still at 0.2. That is freaking gorgeous. It's great.
3 watts.
Yep, 3 watts. Watts went up for sure. Oh,
130, 133. And that keeps going faster.
oh yeah.
Mm-hmm. And that is levitating.
Oh, we're gonna reach 900 here pretty soon.
Mm-hmm. $147.
See, but it's so long and it's thin. And it's, at least it's a little flexible. You know, it's a little flexible so it won't like break on me. Yeah, seems like it slowed down. All right, now I'm gonna get over there in a position. Actually, you know what? Let's turn it up a little bit more. All right, that's a new noise. I'm pretty sure it's just something hitting. Yeah. Just a rattling. Yeah. This got moved around. The shaking moved this closer. Nothing's glued down. Okay, that's what the issue is here. Let's get a. chill speed. Wow, man. What a thrill. I thought the whole thing was gonna like catch fire or something. But look, oh, check the volts over here, bro. On the power supply real quick. That's how much we got coming back into the power supply from the coil. It's like a whole battery's worth. Oh, that's so cool. So, I wonder, I might have to go over to the storage unit and get like 2 things, but that'll be later. So neat. Currently, it's generating 26 milliamps. 24. And I think it did a pretty good job considering nothing's glued down. I mean, everything's been holding its position from its own weight. All right, so we're gonna hook up our lamp. And maybe some LED real quick. And we don't need DC to do that. But I think we can use it though. All right. So this is the negative of the output. I'm clipping right now. It's also connected to the negative or the COM of the multimeter. Multimeter. And a positive, positive. All right, now we need to select the bulb. Let's just do our LED blacklight bulb. 15 watts.
water.
I do have other bulbs. We can try it. We're gonna do this one first We can't do this one. We're gonna pack it up and go home. I am home. Oh man, that's even worse. Definitely don't want those to be touching. All right, I'm gonna turn it on. I'm gonna turn the switch on when I feel like it's on fast enough. I think it's got good torque too, pretty much. All right, I think this is gonna light right up like a Christmas tree. And here we go. 1, 2, 3. Oh, brilliant! And it's brilliant.
Just move the cord. There we go.
The volts are still going up pretty much. 70 volts. DC. It's going to flash a little bit because the degree of separation is 40. 40 degrees of separation. And 70, it looks like it might be it's neat. That's really cool. Alright, so and then we can turn this off. Let it climb up a little bit. That's going to drop down at least to something like 30. I don't know exactly how many volts, and then it'll drop to 70. If 70 is the number, I don't even know. Actually, I've just seen it happen before.
We're just letting this build up, and then he's going to turn the switch on, and then we'll see how it changes.
And the light, so I'll put the light like right here. So 30 volts. Wait a minute, that was 50 volts.
Mm-hmm.
Okay.
$50 on, $30 off, something like that.
So what else could we hook up to the DC rectifier? Could we charge a battery with that? Probably not. Because this battery right here, I used this one. Could be charged. But that's 120 volts, man. That's a lot of volts right there. I think I might have DC motor. I don't really feel like I want to look for it right now. All right, that's cool, right? 137 volts. Seems like we're missing something though, doesn't it? Because we had it up to 100 and whatever before, like 100 and... So I don't know. What we could do is we could hook up the flyback loops on the drive coil here. All right, so let's cut that off. You know we can light the light. All right. So I did 90 degrees with this one. So I did just north at 90 degrees. We're gonna see if we can't get it to go fast. Oh, yeah, I finished this thing that I was inspired by something
What?
and printed wrong. These were supposed to be cube inserts, or like indents, but they ended up being cut triangularly through the middle. I don't know why I did that. I'm pretty upset about it. This was 95% infill. This is a solid piece of plastic, basically. So I was trying to put some bearings in there earlier. I got more bearings coming. Don't know where these. I don't know where everything went. I think it's all in the storage unit. But yeah, I got some cubes coming because I figured. I thought about it actually. 1 inch by 1 inch is thicker than 40 by 20 millimeters by about 5 millimeters.
Cool.
So that field, even though it's a more condensed area, it's going to be that much stronger and reach that much farther than the big ones that I use.
That's these guys moving.
But I was thinking, four magnets on the rotor, like baby pulse motor, on that little tiny one that I did. There's the rotor. No, sir. Well, I mean, it's a representation of what my buddy told me the Dini coil was, made up. What was inside of it. And so this is what I came up with. We got, like 7 strands in this coil. It's inspired, but no, it's not. I haven't looked at any diagrams or anything like that. The inspiration was in the coil. Now, if I look it up, I know that he did bifilar coils. I'm not so sure about this one. I mean, yeah, you probably could have made this one work. It's pretty good though. I mean, this could totally be his stuff. I don't know, really.
And if you pop a question, it'll pop up right here. So STM, yours just popped up there.
Yeah, yeah. Can't say for certain. It's not meant to be it's meant to be more of a freelance thing. There's no actual desired outcome. So like we got the drive coil right here. Then I threw this generator coil on the side, just like bam, and there it was. All right, and then I hooked, both of those ends up to the other end of this. Bridge rectifier. And we got the on-off switch. It's still generating even though it's going super duper slow. Oh no, it just stopped. I was on the verge. It has to be, I think, about 50 volts for it to even turn on. Okay, so let me get it going again. Oh, they just touched one another. You saw it go on, right? Oh, well, I'm not going to do it again. Well, maybe I can. Let's do it again. Let's see if we can do it again. I just don't want to do it with my hands. What the heck? Must have been residual buildup. Because it's not doing it now. It's unfortunate. Back to what I was going to do. It sparked. It was like a capacitor, but I think it was just the coil with residual buildup in it. All right, this is extremely, I would call it efficient. All right, so we're at 10. I believe it's going to be at 0.5 amps or 0.5 watts. Half a watt. Or is it 5 watts? 10 volts and 0.2 amps, bro. What is it? 2 watts? No, it's 1 watt right now. Okay.
You said 0.2. That's
No, you're right. But it's fluctuating between 0.1 and 0.2 amps. So between 1 and 2 watts. And look at our light. Forgot to turn it off. And that's probably why it's going so slow at 10. All right, so what I want to do now is see, thank you very much, 007. There's tons of stuff that he had at his disposal and that he knew about and that he was, and especially the flyback battery swap circuit, you know, he had some great things. And I don't know, maybe we could do something like that with this. All right. Excuse me.
But those batteries could never be charged with a normal battery again, normal charger.
Oh, these ones, if I plug them into this? Ah, okay. Neat. But I was thinking about taking the back end of these strands and running them into the positive end of their accompanying strand.
Do that again,
Do what?
the motion.
Okay, so it would go, all right, diode from the negative end of the coil to the positive end of the diode, out the negative end of the diode to the positive end of the coil. Basically connected like this, with a connector here and a connector to there. And then we can either put a cap on it like we did with this one, because I already did strand one. I did the 28 gauge strand, and that's hooked up with a 25 volt 4700 capacitance. I think I'm about to take, I only have one of those right now. I'm going to take that one out, and I'm going to use the 10 volt 2200 capacitance. I'm going to put a cap in between each. There's only 4, even though there's 7 strands, there's only 4 connections made. Therefore, you only need 4 diodes. Right? I'm pretty sure that's right. Because the 28 gauge is hooked to a transistor 1 of the 26 gauge is hooked to transistor 2, 3, and 4 are hooked in series and then hooked to a transistor, and then 5 and 6 are hooked in series and then hooked to a transistor. So there's 2 series circuits, and then 2 circuits are parallel to those 2 series circuits. So you basically have 4 strands and 2 are longer.
Hold that for a second. Hold that for a second.
All right. Brother man's getting a chair and sit down. It's good. All right. Thank you.
Mm-hmm.
Yeah, man. That's perfectly right on. All right. And we're at, I just want to try and get a good, I want to get about 1200 RPMs on this. All right. We are now at 12 volts in, 1.2 watts. 1.2 watts. And all those little coils, no matter which way I arranged them or whatever, they couldn't get speed like this. So I just kind of, it's all right. I'm not worried about it. I'm going to have to come up with another design. It'll function better with this drive coil. Yeah, that even at this speed, that coil is only generating between 20 and 30 milliamps of current. Altogether, at like my fastest reading, you know, like this is going super fast, and still not even generating 100 milliamps. I think 100 milliamps is a good base line if you're trying to run anything you have around 100 milliamps just to start, and that's running your very basic small DC motor, whatever. If you don't have 100 milliamps, good luck. It's like a plateau of power. It's amazing what 100 milliamps compared to 95 milliamps. All right, so we're at 15. So yeah, 15 volts, 0.2 amps. And the amps are just, it's great how low they are with the 26 gauge. It's freaking phenomenal how low they are with 26 gauge wire right now. It's going so fast. That's why. Directly correlating with the speed. $800.
Nice.
So do you think it would even be safe at this point to try to get to 1200?
Mm-hmm.
$17.2 and 0.2 amps. We're all the way up to 17 volts and we're still only at 0.2 amps.
Wow.
Yeah, I'm wondering, I think we might have to change the shaft.
Wow.
Let's just double check that.
Okay.
One more? One more. Yep, that was the second one was accurate.
I didn't get that. All right.
Alright. Alright, let's see. Oh, this thing shut itself off. $162. That was my tack meter.
Wow.
74. So it's it doesn't matter like how many volts are in there. It'll always go down to, looks like 75. It's awesome, but I don't know about that though. But that's what it does. All right, one more time. All right, I'm gonna cut the power. I really think that shaft needs to be something sturdier than the metal that it is. So I'll look online and see what I can get. Mm. Nice. So I don't know which way could I go with this. If I wanted to extend the drive, what should it, like, dimensions should the pickup coils be, or the rest of the drive circuit be? I mean, I could set it up with these, but I'm thinking I want each one to be a single strand. Right. Yeah, as for like that meticulous like replicate, I could never replicate anything. I'm not, my hands shake too much to even have that in my, my it's not even in here to like copy to a T. To be inspired by doesn't mean to totally embrace what it is. It's just an idea or a philosophy about it that you embrace. To be inspired means that you maintain most of it as being yours. You know what I mean? So, Tesla's 369, with the Rodin coils and all that stuff, are, Tesla's 369 could have been way different than Rodin's 369. It could be way different than my 369. You get what I'm saying? I mean, if you don't, I don't understand. I don't understand how that could be like misunderstood. Like, yes, it was an inspiration, but no, this is what I think that it means, and here's my demonstration of how that works. So, is this a John Bedini? No, it isn't. Was it inspired by? It was inspired by a viewer of mine. I asked what the coil was, how, what was inside the coil. Was it more than one strand? Was it, um, multi-filer, like more than one strand? How big was the wire? What was the gauge of the wire? Important information. This is kind of what I got. I mean, the 28 and the 26, I got that off of a presentation about a year ago. I saw it was probably 10 years old, the presentation. But I watched it a year ago, and those two numbers stuck in my head, so that's where the gauge of the wire comes from. All right, so yeah, I need some inspiration right now. So let's see here. Where do we want to go with this? Now, I did say I was going to do this, so I'm going to do this real quick. And these are the caps that I'm going to be using for this loop. I want to call this a recycling system. So in case there's an overflow of electricity, it'll flow down this circuit or this connection back, and it'll recycle itself through the system. So wire 1. That's why it's good to have these marked. Good way to mark them is to do an ohms test. And once you connect it to the right wire, the ohms test will give you a reading. And if you're not connected to the right wire, it'll read overload. And that's only if your ohms are, like, I think about 2 will register, because that's the lowest. So it's like you're doing your diabetes reading, and it says error, cannot read. You're like, what? Why? What's wrong? What did I do? Why are you broken? It's not broken. Your blood sugar is so low that it can't read it. Go to the hospital. All right, number 1. It's hooked up. Number 1. It's hooked up. Now we're gonna do our second. Hook up, and that's gonna be to first series, which is 2, 3, and 4. So what we're going to do is we're going to hook it to 2, because that's the start. Wait a minute. 4. Because this is the end. The end is 4. All right, I was just grabbing the wrong wire. Didn't take too long to figure that out. All right, and so it'll be 2 on this side. And this is it, folks. And will it make it run smoother or better? Maybe. Did it need to run smoother or better? Not really. But we're gonna do that because that's what we do. It's like, you're gonna buy 1 steel ball? I'm like, no, dog. You gotta buy 2. All right, and in the out. 5, 4, 3, 2, 1, 0. Blast off. 9 volts. Just trying to make sure none of these are just gonna randomly. All right.
All right, why don't you give an update on what you're doing?
All right. Hey, what's up? So I'm doing this is a pulse motor, and we're currently generating electricity. Right now, I'm hooking up I call it a flyback, but it's not really a flyback. It takes the energy that doesn't, that can be recycled, and recycles it from the end of the drive coil to the beginning via diode. So this is all the energy that doesn't get grounded on the first rotation, basically. Could be very little, it could be more, but so
Nice.
yeah. Each one of them has a 10 volt capacitor on it, 22 micro farad. Yeah, so yeah, and I know they're working because the amps are up a little high right now. 0.4 milli, or no, 400 milliamps, 16.1 volts in right now.
Nice.
Yeah. This is a 32 gauge coil, 22,000 turns in it.
This one right there.
And then we're going to get an amp reading real quick. 26 milliamps. Because it's 32 gauge, you don't get any current off of it. Alright, with those capacitors hooked up, we are, I don't know, it's weird, we're getting,
Nice.
yeah, not bad. I'm going to give it like 15 seconds and do another one.
Okay.
Because it looks like the volts are going up pretty consistently, but just slow. Yeah.
Uh-huh.
So 800 is getting into that region that I like to call fast. Especially for something uncontained and basically on a stick of metal.
Yeah,
That's fast.
it touches the ground. You can see it right there.
But that, yeah, man, they're working because normally I could get it up to either that or a transistor is blown. Could be very possible.
I bet Mike does is hovering, and he's just waiting for us to get the mica. Nice.
Oh, okay. Maybe I just turned it up too fast this time. Because it's starting to, the amps are starting to taper off a little bit. No, maybe not. There you go. I don't know.
I'll pop up and go get a visual on that power source here in a minute. What?
It's more like it.
Yeah.
I mean, and if it can still work that good with a blown transistor, it's working pretty good.
Let's check this out. Wow. Nice.
Heck yeah. I was wondering, I don't know. Because I know that that's way too many volts for like pretty much anything. And then it's not enough amps for anything.
It's going up.
Yeah,
Upside down view.
it was at 17.5 and it went down and then it went back up.
Okay.
That's awesome. See, now what I think would happen, what we need to do is we need to put a cap in this circuit somewhere. Because the coil is acting as a capacitor to 74 volts. And it's pretty much, as long as you can produce 74, I'm not exactly sure how it works, but I'm thinking if we put a capacitor in there, that it would stabilize the flash here. Like,
I see. So smooth out the output.
yeah, like when you start from the bottom and you work your way up, it's flashing really bad at the beginning.
Right.
You know, having a capacitor there would deal with that.
Because that's when it hits the coils.
Yeah.
Okay.
That's when the magnet passes and generates the electricity. And it's doing that all the time anyway, except the frequency's a lot higher when you are going really fast, so you can't see it, but it's happening.
It's happening. How would Bill Nye the Science Guy say it?
I don't know. I don't know. But I'm printing another one of these right now with a little bit less infill. I think this is going to be tight. It's going to be awesome. It's going to be fast.
What are your plans with that one?
No, just to see if I can't get, thousands of RPMs with what I have out of it.
Right.
That's the basic plan. Because, I mean, this one, if the shaft was, things were sturdier, I bet I could get up to about 1,500, maybe 2,000. but it itself, it isn't perfectly level or. Mm. All right, so like one more thing I could do. See, I'm developing a pile of transistors that I've been using in breadboards that I will test to see which ones, because it's like once, like you can see how well it's running. So like one transistor blows and the other three are good, but you don't know which one it is because you hooked it all up at once. So, but I think, you know, if they were, three of them were firing. Now, the one that's busted, should that one be hot or cold? If anybody could tell me that one. Because the thing is, like, three of these are cold and one of them is hot.
Mm-hmm.
And I think this coil, with the way that I have it hooked up, man, is actually perpetuating the motion to a certain extent beyond the power being off. So all these capacitors and directional diodes and all the energy that's generated when the magnet passes goes in and around like that. So it goes around like this, basically until it's all gone. So it won't go forever, but it'll go longer than it would if it didn't happen.
Yeah, you can see that.
And that's the part of the EMF, I think. That's residual coming from the coil back into the power supply. A buddy of mine said that would happen. Only it wasn't happening. And it didn't happen all the time. It just happened some of the time. But yeah, that happens. Depends on how you got your coils hooked up, I think. So, oh yeah, that's right. Might as well do that. You know what? They all feel pretty good. I would like to test them. So, magic test number is 0.7. transistors are switched up. So I do think that having the capacitors hooked up the way they are is causing there to be more amps by a little bit. I think it's just because there's more. I don't even know. I'm gonna say because there's more wire there, but that would be less amps. That'd be more resistance. All right. Well, there's a transistor swap out. Very cool. I'm just happy that it's going that fast. I really want that other rotor to turn out well. Running right now. So I think for the drive, we're gonna keep it simple. This simple. I mean, it doesn't have to be more simple, but at least this simple. Like one slot will drive. I might change my mind. I'll change my mind a lot. So that'll work out. Well, that's going so fast. I think, yeah, like I said, the caps are definitely making a difference. Whether it's for better or worse, I can't tell you right now. There she blows. 812. All right, so that's good. We're gonna call it 800, in between 800 and 1,000 on the video description. All right, and I don't know, I call that a success.
Yeah.
Heck yeah. And I'm like, because this came off the connection of another setup, this transistor board here. So I'm like, I'm just gonna make it so I can switch the connections. And this is what I came up with. You got your one strand, 28, you got strand of 26, and then you got 2, 3, and 4 strands in series. That's the third one. Then you got 5 and 6 in series, and that's the fourth one. Boom, and that's 7 and 4 with 2 series circuits and 2 parallel circuits. This is phenomenal for what it is. I think this is great. All right, I'm gonna cut it back. All right, so the next thing I'm gonna be working on is getting such a setup for the rotor that's next to it. See if we can't get that thing whipping in about, 2,000 RPMs or something. And then the reason why I think it might actually go that fast is because there's only 4 magnets on it. So that'll work good. And those bearings are ceramic in there. They're like really, really good bearings. The only thing that this thing doesn't have going for it is that it's lopsided. Awesome. I don't think it's gonna go that fast though. Not this one, but the one that I'm building right now should be able to go like 5,000 if everything's true. Here you go, man. I gotta stretch. All right, well, thank you very much. Peace out. Have a great day. And we're going to continue. We're having fun. As long as we're having fun, I'm in, man. That's it. So, peace out.